Good afternoon and welcome to the Preservation Association of Lincoln Brown Bag Lecture Series. My name is Eileen Burkt and I'm the coordinator of these brown bags. Our lecture today is jointly sponsored by the Preservation Association of Lincoln and the American Institute of Architects Lincoln chapter. If you're interested in these programs, we have brochures at the back of the room. You can join our membership. Our membership is also available online at preservelincoln.org. Our speaker today is Dan Worth. Dan is senior principal at BVH Architects in Lincoln, Nebraska. Dan has been with BVH since 1984, working on both the Lincoln and the Omaha offices. Dan is a historical architect and fellow in the Association for Preservation Technology International and has worked on many historic projects ranging from local landmarks such as the Nebraska State Capitol, the Bryan Home, and the old federal building rehabilitations, to national landmarks such as the Gateway Arch in St. Louis, Mount Rushmore National Park, and many projects at the Smithsonian Institute in Washington, D.C. Dan is also a founding board member of the Preservation Association of Lincoln and chair of the Nebraska Historic Preservation Board. Dan was principal in charge and project manager for the BVH project team for the Nebraska State Capitol Masonry Restoration Project. Dan's talk today will summarize work of the 15-year restoration project, giving everyone a perspective, one of the largest restoration projects undertaken in the state's history. Please join me in welcoming Dan Worth.
Thanks, Eileen. It's great to be here and see a lot of familiar faces. A lot of people that were involved with the project too. So I hope you'll all contribute to the talk today through comments at the end of the project or end of the presentation. As Eileen said, the talk today is basically a visual summary of the work that we've done on the Capitol over the last 15 years. And the postcard that went out to advertise for the talk today said that this was one of the most significant projects on the building since its original construction, and it really is. It's significant in a number of reasons, really. One, the cost, of course. It was a very expensive project, probably 5 times what the Capitol cost to build originally. But I think more importantly is the significance of extending the life of this world monument, and it truly is a world monument. It came at a critical time in the history of the Capitol in its deferred maintenance to extend the life of the building easily 100 to 150 years. And then again, it's significant for the state of Nebraska because the state and the legislature and the governors that oversaw the history of the restoration, the continuity of the restoration, supported it almost unanimously, and that is unheard of in our political climate today, as you may imagine. So, for a preservation project to have that kind of support, not only from grade school children to our state legislature, it's very significant. And then finally, just personally, and I can speak for the project team that's here as well, it is truly one of those once-in-a-lifetime experiences to be able to work on a project of this magnitude, of this importance, from the very beginning to the very end of the project. So with that, I've got close to 100 slides today, culled from back in the office. We were looking through all of the slides and images that we've accumulated over a 15-year history of the project, close to 5,000 images that we've culled to come up with those that you'll see today. So it's going to be fast-paced, but it's going to be like looking through a scrapbook back in time of the project. We've got a little timeline here to give you just a snapshot of all of the events that have occurred on the Capitol, of course, beginning with its construction in 1922 and its completion in 1932. But our work essentially began in 1995 when our team was commissioned to do a comprehensive assessment, exterior envelope assessment of the Capitol, which then subsequently developed into a number of phases of restoration work. Of course, you know, the Capitol that we have here in Nebraska, or here in Lincoln, isn't our first Capitol. The first territorial Capitol was built in 1854 in Omaha. It was a temporary structure that was soon replaced by the second territorial Capitol, which now stands, the Omaha Central High School stands on this site. Of course, then in 1867, when Nebraska achieved statehood, the Capitol was whisked away to Lincoln, and our first statehood Capitol was built here in Lincoln in 1868. It suffered from a multitude of structural and material deficiencies and was soon replaced with our second state capitol here in Lincoln in 1880. I think it was constructed between 1880 and 1889. And again, it was almost from the beginning when it was occupied, it suffered from a malady of poor exterior materials, structural issues. So about 1919, the legislature determined that it was time to replace this capitol. Of course, you all know the history of Bertram Goodhue and the competition that was held by and overseen by Thomas Kimball, one of our most famous Nebraska architects. Of course, Goodhue's design was chosen from a national competition, and this is his competition drawing. It was a very innovative design, fusing high-rise building technology with more traditional and transitional design elements. One of the reasons Goodhue's design was chosen, of course, was for its ability to be phased. And here you can see the second capitol being enveloped by the new state capitol. The perimeter of the capitol was, the new capitol was built. The old capitol was torn down. People were moved into the new sections, and then the tower was built, completing the capitol itself. Another reason that Goodhue's design was chosen because of his devotion to durability. And with all the problems that Nebraska had with poor construction and poor materials in its previous capitals, a lot of attention was paid to the durability and the quality of materials. Something that we are blessed with today is that heritage that Goodhue brought us. The building rests on deep pilings, very stout concrete foundations. Here you can see some of the construction photos of the new high-rise steel framework that was used to build the tower. Ultimately, some of the fusions of the new technology with more traditional technologies caused some of the issues that we faced in our restoration project. Here you can see the Capitol Tower rising in its final phase of construction. And then again, one of the things that we're certainly blessed with in Goodhue's Capitol is the infusion of the arts with the architecture. You know, the most notable figure of that is the bronze sower atop the Capitol, but throughout the building design, excuse me, Goodhue and the artisans that he surrounded himself with incorporated just a very rich iconography of symbols and features into the Capitol design. So here we are in 1995. We were hired, as I mentioned, by Bob Ripley and the Capitol Commission to undertake a very comprehensive investigation. Basically, the whole envelope from the very top of the dome, including the roofs, the masonry surfaces, the windows, down to its base. And if I go a little fast here and start to use some terms that are a little foreign to you, we've included this diagram to help you discern some of the the terms that we'll be using. Of course, we've got the dome up above, the drum underneath the dome. We've got the octagon, which the dome and the drum sits upon. The four turrets at the corner, the turret walls or the observation deck that we refer to, the tower shaft. We've got the clear story, the fifth floor roofs, and then a series of roofs, the transepts roofs and the quadrant roofs. And then finally, the base of the building above the terrace, and then the base of the building below the terrace. And then, of course, much work was done on the principal entrances, the north, south, east, and west entrances of the building. As I mentioned, our survey of the exterior began at the very top. We used a variety of techniques to inspect the building, including rappelling from the very top of the dome, inspecting the tiles of the dome and the construction techniques at the dome. We used swing stages that were hung off the sides of the building. You can see some familiar faces in our slides here today. A little chilly on that day. We did a very thorough analysis of just about every piece of stone on the building. Around the base of the building, we used rolling scaffolds to get up close and inspect the building as well. What we found from that investigation was that the dome of the Capitol was in fairly good condition. While the expansion joints were failing, there was some water starting to enter into the dome structure. There were a few hairline cracks at some of the dome tiles, but around the dome and the drum, some of the more severe problems started to show up, where the stone and the tile surfaces started to intersect. You can see on the right-hand image there some of the cracking that occurred because of differential movement between the different material systems. At the observation level, or the tower walls, if you've been to the Capitol and been out on the observation deck, you peer through these screen walls, which are basically limestone walls that are clad over soft brick, common brick. And as you can see on the slide on the right, those walls were starting to expand and literally explode. They were leaning. There were a lot of cracks, a lot of water infiltration that was occurring. At the turrets, we saw similar conditions. The slide on the right, the lower left-hand corner, you can see just a tremendous amount of water that was coming in to the underlying material, the finished materials on the underside of the turret. But these turret walls themselves were starting to move away from the large capstones. Again, we were seeing a massive amount of water infiltration. The flashing systems underneath some of those large capstones were failing. Excuse me, as we moved down the tower, we saw, I believe by our survey, we found at least 400 spalls of stone that were occurring. These are caused, as you'll see a little later, by iron straps that hold the stone veneer back into the brick backup. Those were rusting because of water that was infiltrating the joints. And we saw kind of a curious repair that had been done back in the 1970s. It turned out to be kind of a blessing in disguise, because it allowed us to project how much stress was occurring and how much cracking was occurring in the facade itself. You can see in this slide that someone in the 1970s had come along and smeared some epoxy sealant over some cracks. Well, it really didn't do any good, but there was a tremendous amount of vertical cracking that was occurring up and down the whole tower limestone veneer. Excuse me while I take a sip here. What was happening, as I mentioned before, through a lot of research, through the archives of the Capitol and correspondence between the architect and the contractor, is we found that the existing expansion joints at every floor of the Capitol had been literally packed full of material, and those expansion joints weren't allowing stresses to be relieved at each of the floors that you would normally find in a high-rise structure. So what was necessary to do was to come back in and rebuild all of those joints and put in a clear expansion joint that went from the outside facade clear through the wall system that allowed the building to move as it should. Many of you probably know, and some of you may not know, that steel structures, especially high-rise structures, over time will foreshorten. The steel will actually shorten, and all of that stress that was contained from that foreshortening was transferred into the exterior limestone walls, and that caused all those vertical cracks up and down. Here's another close-up of some of the spalls that we were seeing because of the iron anchors. Here's Charles DeVries helping us do an inspection opening back in 1995. When we pulled out one of these stones, you can see the brick backup actually came with the limestone itself. The mortar that was used to lay up the stone to the brick backup was so tenacious that it actually pulled the surface of the brick off that wall. And then, of course, probably the most visible sign of distress on the Capitol was the organic growth that was occurring all over the facades. Wherever water would run down the surface of the building, you see this little black growy stuff that was basically algae. Back in the 70s, the building was sandblasted, unfortunately, and through that sandblasting, it produced an environment. If you can imagine the porousness of the stone, it created a great environment for these little algae organisms to grow and to thrive. It occurred on the base as well as the tower. We did a multitude of tests to see what would be the best way to remove the growth. And we happened upon a technique that was being pioneered by the French called Facade gommage, which literally means erase facade. It was basically a microabrasive technique utilizing a silica substance that was about the consistency of talcum powder. At a very low pressure would help abrade and take off the organic growth, while literally improving the surface of the stone, helping it ease it back down to more of its original surface texture. And then around the entrances, we found a great deal of distress. As you can maybe see in this slide, these giant cracks over the large jack arches of the primary east and west entrances. These were caused by forces of freeze and thaw cycles of the terraces above, pushing these stones outward and cracking those. As we crawled underneath, and thanks to Matt Hansen and some of his explorations, underneath some of the stairs, you can see we literally had stalactites forming from salts coming through the failure of those waterproof membranes. And those salts were literally, just causing the stones to just become super saturated with chemicals and salt freezing or salt thawing chemicals. And then finally, the roofs. There's, I think we estimate there's about an acre of copper roof, about 2 acres of copper roofs at the state capitol. And there were quite a few distressing situations that we found at those roofs. You can see some sandbags piled here. These sandbags were literally holding the roof down to the decking because the fasteners that holding down the copper roofs had failed or were missing. And there was quite a bit of leakage. You can see this is taken from the attic on the underside. The gypsum deck was literally decaying and falling away from the drain lines around the roof drains. Part of our inspection report in 95 and 96 involved a great deal of research into the Capitol Archives. For those of you who have not seen the Capitol Archives, it's a wonderful treasure of drawings, original drawings from Goodhue's office, shop drawings, specifications, correspondence that relate to the Capitol construction. It was very, very helpful. There we found the original stone shop drawings. This is a very hard drawing to see, but it literally shows every stone that was cut and fabricated for the Capitol facade. We turned those into observation or drawings that we took out into the field, and we mapped, I think it was a dozen different kinds of distress that we were seeing on the facade. This shows you some of our field notes from those observations. From these observation notes, we built a CAD database of the facade of the Capitol. It was a relational database where we mapped all of that distress back. And from that, we were able to plot and figure out and quantify the amount of distress that we found in the limestone facade. I come back to this image where this epoxy was smeared on a crack back in 1975. And you can see that line of spalls that we knew in 1975 and the new spalls that we found in 1995, as well as the number of cracks. The Chemi epoxy smeared gave us a benchmark of the number of cracks that were there in 1975. And then from our observations, we projected that we had close to 2,500 total cracks. So you could see the number of cracks was rising as time went on. So if we didn't correct the situation, we'd end up with a facade that was just basically full of cracks everywhere. We did our comprehensive document. We prepared a number of different scenarios. We looked at 5-year up to 12-year restoration plans. We projected costs. We took that document to the Nebraska legislature and presented it, and everyone embraced it very enthusiastically. So in 1998, we were given the go-ahead to begin the project, and the project began at the north entrance. Now I'm going to run through some of these slides very quickly, but it gives you an idea of the work that we undertook. You've probably seen this little crane hanging around the Capitol for about a dozen years now. And it was a very nice little crane. It was from Italy, and it was very portable. They could fold it up, move it around, and it was great because it could lift some pretty heavy chunks of stone very nicely and very quietly. So the majority of the work that we did regarding the limestone facade was carefully dismantling certain areas, especially wing walls, parapets, those kinds of things that had the soft brick backup, because that brick backup was taking on moisture, causing a lot of distress and degradation. So you can see here the workers from Mark I Restoration, our restoration contractor, carefully dismantling the north stair walls, locating those in a yard, marking the numbers of the stones exactly where they were removed so we could put them back into place. We removed the stair treads to get down to the underlying concrete fabric. There we applied new concrete to stabilize certain sections of the stairs. We rebuilt the wing walls. Here you can see the reinforcing being tied for the concrete cores of those wing walls. And then one of the key things that we did in all of our work as we rebuilt the limestone facade pieces, we used concrete block backup instead of brick backup, because the concrete and the limestone have more similar characteristics in expansion and contraction, rather than the brick and the limestone, which have various or widely varying degrees of expansion and contraction as well as water retainage. We also used a conservation approach on many of the repairs on the Capitol, where we, on significant pieces of stone that were carved or had some ornate work done to them, if they were cracked, we tried to conserve those as best we could. Here shows an example of a workman using stainless steel dowels, pinning those stones back together and using an epoxy matrix to literally glue that stone back together again before it was reinstalled. And here's a couple of snapshots of the north entrance close to being completed. Then we moved around to the south entrance. There we found very similar conditions, only on the south entrance. If you've been to the Capitol, you know that there are two deep ramps that go down to service the loading dock down at the basement level. There we found that those retaining walls holding up those large expanses of earth on the sides, those were leaning and starting to fall apart. So this entrance was quite a logistical exercise on how to pin certain pieces back together, how to carefully demolish others while supporting retaining walls and knitting it all back together with new materials. In these two slides you can see how we reconstructed certain pieces of the stair with new concrete stair material before we reapplied stone and granite treads, and then certain areas of the retaining wall, the old brick masonry retaining wall, were replaced with more contemporary concrete retaining wall structures. And there's a slide of it as it looks today, all put back together. Then we moved around to the east and west entrances to take care of these large, very important stones that were cracked and deteriorating. There again, we carefully dismantled the stairs. We took the stones off the railings and salvaged as many of the stones as we could. We rebuilt the stairs with more concrete fabric. In this case, as you can see in this slide here, we developed channels for water. Water is going to infiltrate those granite treads once we replace them over time, but the trick is finding a way to get the water out of that system. So we developed little trench drains, basically, in the staircases themselves to help rid the water if it ever got into the system again. And then we fabricated new jack arch stones. Here you can see those being delivered from the Indiana limestone quarry. I might mention that at the outset of the project, our project team did go visit the Indiana limestone quarry, where the limestone was originally taken from for the Nebraska State Capitol, and the vein of limestone is still being quarried that the Capitol stone came from. So we were very fortunate in finding good matches for stone for those stones that we did need to replace. Here you can see in these slides we're putting new, modern, more superior waterproof membranes underneath the stair platforms and underneath the treads before the paving stones were relaid. And here you can see the stones as they have been finally inserted and tooled back into shape. Probably the most visible sign of the project as it was going was the 2 or 3 years that the scaffolding was on the tower. One of the reasons that Mark I Construction was chosen as our restoration contractor was for their innovation that they brought to our project team for erecting a scaffold around the building that allowed very flexible working conditions, but saved the state literally millions of dollars in scaffolding rental fees. I think we figured that rental for scaffolding around the tower was close to $18,000 a month or something of that tune. So every month that we could save on scaffold rental was money saved on the project. As I mentioned before, the major work on the tower facade was around those pressure relieving joints. Here you can see the workmen have removed stones above that the steel ledge angle and below the steel ledge angle, giving them access to that so they can install new expansion joint materials, installing or going back and priming and painting those ledge angles should there be any rust. We coated those again with lead flashings, installed new pins, and then reinstalled the stone. Here you can see a nice little cross-section of how that new expansion joint, flashing materials, weep materials, all of that went back into place. And here you can see the mason relaying the stone with its little blocks and starting to seal up those joints. That happened on every floor, and you can still see very barely around the Capitol Tower facade where that work occurred. Right after it occurred, it was fairly visible, but over time, as weather has occurred, that differentiation of new work versus old work is starting to disappear, and all that work is starting to blend back together. At the turrets, we had to move some really, really large stones, 13 floors up in the air, and had to innovate on some materials, on some methods to swing those stones around onto our scaffolding. Here you can see after all those stones have been removed, our workmen are back in here putting new lead flashing over the top of the turrets. Here you can see the slip paper being installed there, and then workmen installing the final capstone after all of that flashing and repair work had been done. And of course, during the course of the project, the state received I think it was a $500,000 grant from Save Outdoor Sculptures for the conservation and repatinization of the bronze sower. While the scaffolding was up there, it was a popular place to go up and visit. A number of folks went up there and had their pictures taken with the sower. As I mentioned, the entire limestone facade of the tower, the Capitol was tuck pointed and cleaned after the masonry restoration work was done. Here you can see workmen grinding out all of the joints. As I mentioned before, the tuck pointing that was in the limestone facade was very tenacious, very, very, very hard. Was not allowing the facade to move as it needs to, even just through regular temperature swings of our climate. So we did some formalization and came up with a new mortar mix and found the original mortar color as well, which was basically a white mortar that we used for tuck pointing the entire Capitol. That work on the limestone carried into the courtyards as well. And the slide on the right here shows a technique, all those new vertical cracks that we found throughout the facade. We used an epoxy injection technique where we drilled a little hole at the top of the crack, a little hole at the bottom of the crack, inserted a little tube and injected epoxy into that crack until it started to ooze out. So we didn't have to remove that stone, but repaired it in place. That worked very nicely. Here you can see the work continuing in the courtyards. And then we moved to the roofs. As I mentioned earlier, about two acres of copper. Part part of the sustainable portion of our project is we recycled about every ounce of copper that we took off of the roof, sold it as scrap copper. And I'm trying to remember, I think the state actually made a little money on the copper recycling, because when we started the project, at least the copper roof portion of the project, copper was selling at about a little under $3 a pound, and by the time the roof was done and we were delivering our last load of copper to the recycling plant, it was well over $4 a pound. So it was a good thing to do. Part of the roofs also included the 5th floor balconies. There you can see we've got quarry tile roof decks. Quarry tile was laid directly on concrete roof decks, and we're experiencing quite a bit of moisture infiltration and deterioration. Again, at those balconies, we carefully disassembled the parapet walls, removed the soft brick backup. The lower right-hand corner, you can see the demolition is almost complete down to the concrete deck. And then we rebuilt those parapet walls with concrete bricks on the interior, and then a more solid brick surface on the backside rather than the stucco covering that was there originally. That allows the wall to actually breathe and give off moisture should it ever take it on again. And then for the quarry tile roof deck, we came up with a system where we fused the original quarry tiles to concrete roofing pads and put that over a waterproof membrane roof, a more contemporary solution for that, allowing the state, should there ever be a roof leak, they can easily remove those quarry concrete roofing tiles, access the deck, and repair the deck and replace them. As we move to the copper roofs, we have a variety of conditions, low slope, medium slope conditions. You can see the roof slopes from the inside courtyard wall down to internal roof drains here. And at the upper roofs, they slope down to gutters, which then dump water down into roof drains down below. Just before we started the roof project itself, a storm came through in October of, I'm trying to remember, Bob, it was 2007 perhaps, 2006, a little earlier than that, okay, and blew off part of that copper roof. It was right over the Supreme Court area of the Capitol. You can see, it's kind of dark, but you can see part of that copper roof just peeled away because of the lack of anchors to the gypsum deck below. As we took off the old copper roof and recycled it, we made a number of other improvements to the roofing system itself. There you can see the poured gypsum decking that forms the roof structure. We actually laid down treated sleepers. We put in rigid insulation, a layer of rigid insulation, and then a new plywood deck material on top of that we could adhere the new copper roof to very solidly. We also added a number of roof drains, and here you can see a workman framing up new crickets to allow for those additional roof drains, and we increased the slope to those roof drains so we had better drainage all the way around on the roof system itself. And then under the entire copper roof is a layer of ice and water shield. So we basically have two roofing systems here, kind of a belt and suspenders, but it's a very superior installation, one that should last, if well maintained, 80 to 100 years. On the low slope areas, we used a very traditional method of the flat pan soldered seam coppered roofing materials. Here you can see it in a detail in the lower left-hand corner. And then on the more moderate slopes, we used a more traditional system of a board and or a batten system. It was a more durable roofing system, we felt, in the long run. As part of the work, we also went on the interior of the building, added new connections, new roof drains. Here you can see new flexible hubs underneath those roof drains, so if there was ever any temperature movement within those attics, that we could accommodate that thermal movement. As part of our roofing campaign, we paid a great deal of attention to the quality of the workmanship. Almost monthly, we had an inspector go out, cut actual solder joints, inspect those under microscopes to make sure that we were getting the best soldering job we possibly could. Even before solderers or the workmen were allowed to work on the project, we went through a strenuous testing situation where we had to make sure that they were able to pass high quality standards. And you can see in that slide just the beautiful workmanship that we resulted in. Roof hatches, the flashings that were let into the sidewalls, and also the terminations. Here you can see the one of the transept roofs. This is looking south as it was being laid in. And then as we were coming around the bend and finishing the project up, the northeast quadrant over the governor's office, we'd like to finish the project over to the governor's office, of course. And here shows the last bit of copper roofing that was laid in late 2010. We did our final inspections late last year for substantial completion. Of course, the yards that were around the Capitol were restored this spring, and the project is substantially complete. There are a few little odds and ends left to take care of, but we're very proud of the work that was done, and we believe that the state of Nebraska should also be very proud of the way they've supported the project and the care that has been given the building over the last couple of decades. There's a few final slides of the finished product. All the stones back in place, nicely cleaned and tuck pointed. SOAR repatinaed, the dome restored, the north entrance walls restored. And all of this couldn't happen without a good project team, of course. Here's a few of the characters that helped on the project throughout its history, including contractors, our consultants, and folks from the Capitol Commission. Here's a kind of a full roster of those who helped, beginning with the Office of the Capitol Commission, of course, our team at BVH, Weiss Jenny Elsner, who is our prime consultant, Mark I Restoration from Dalton, Illinois, Midlands Engineering, who did the fine copper roofing work, and then Alvine Engineering, who helped with a small bit of plumbing and mechanical work as we did our roof project. So with that, looks like we have maybe 5-10 minutes left for any questions that you may have. Yes?
Was the 1973 restoration based on incompetent advice? Or was it just not mature in terms of design professional expertise? And did what this project restoration do fix the damage that was done in the mid-70s?
Well, to answer the first question, I don't know if I would call it incompetent, but I think it was ill-advised. The sandblasting of the limestone was not a good thing. The tuck pointing regime that was done was not thorough, and some of the repair techniques on the stone, as you saw, were ineffective. So the money that was spent in that campaign was probably not money well spent. The project, this project, hopefully we corrected many of those maladies that were caused during the 70s campaign. We feel that the stone cleaning technique certainly helped the microclimate for resisting algae growth. We did a very thorough tuck pointing campaign, which really puts the facade back into prime condition with a more appropriate, I'll say, mortar mixture. And we did add a few enhancements along the way, some that I didn't cover in the talk today that we think will pay big dividends over the life of the project and into the future.
Another question, Bob? You might mention one of those enhancements, mention where the insulation was added to the building as well.
Oh, yeah.
The very first of the building's history, I might add.
That's right. The roofs were basically uninsulated. So now the building is a little more energy efficient. So that's a good thing. So hopefully we'll see lower utility costs in the future because of that as well. Any other questions?
What was the total cost of restoration?
It was just a little bit under 54 million. I think it was like 53.7 million, spread out over a 12-year period. So the project pace was really dictated by appropriations by the legislature, and based upon the economic cycles that were going through our state at the time. So it really almost paralleled how the capital was built. It was kind of the pay-as-you-go way where the state can't go into debt, and the legislature did the same with the restoration project, which is very admirable. Any other questions? There certainly has to be some.
Dan, it looked like the piping under the roof structure going up to the roof drains, it looked like that was like braided wire piping. Was that for movement?
It was, yeah. We installed a flexible connection between the rough drain pans themselves and the rigid piping underneath to allow for any expansion or movement that might occur.
I mentioned that we doubled, you may have mentioned, we doubled the number of roof drains.
Yeah, Bob made a comment, we doubled the number of rough drains. That was a chronic issue with the old roofing system, as those drains were really overloaded, and we just couldn't get the water off the roof quick enough. And so in many areas you had horrendous ice dams and other things that just caused more and more distress. So we found a way to introduce those extra drains, and hopefully you don't even notice it. So. Yeah.
I think what your talk demonstrates is how this was really a collaboration of a lot of talented people, down to the contractors to the structural engineers that had to figure out difficult things. In any good project, if you can have that kind of collaboration, you really don't make it a success.
It really was. It was probably a case study in the collaborative process, both technical, creative, and even on the craftsmanship side. No idea was criticized. We explored all different kinds of solutions, tested those before we implemented them. I think the best testament is everybody is still friends at the end of the project, and because of that, because of the project, we really have gained some lifelong friendships that are very special to us too. So, yeah.
Is there a scheduled time where it's going to need restoration again, or do you just kind of wait and see?
Well, funny you should ask. We're probably on cycle here, not too far in the future to probably go back and do another envelope assessment to see how things are holding up. Those kinds of things should probably be done on probably a 20 to 25 year basis. So we started this in '95, probably 2015 or so. It's time to start looking at those again. A building of this magnitude, it seems like you start one project and one it ends, another one starts up. It's just a kind of continuing cycle, so. Yes, sir.
You gave a time estimate for the building now?
Excuse me?
You gave a time estimate for the building now, based on this.
Oh, how long it could last? Oh, yeah, this building could easily last 1,000 years or longer, just because of the quality of the materials and the workmanship that's been put into it. The key to that is just how it's maintained, and especially those systems, the roof systems, the wall systems, and the windows too. How it's going to face, you know, the rigors of the Nebraska climate is the key.
In '57, when I was a student in architecture, I chose the Capitol, much to the chagrin of a lot of my more progressive fellow students, for a history project. And part of what I did is went and talked to a fellow named Ellen Ress, who was then the state engineer, and his first job had been a timekeeper for the construction. And I asked him the life expectancy of the Capitol. And he was very disturbed at how it was being maintained, and estimated 50 years.
Really?
So we've
Yeah.
obviously extended Ellen Ress's estimate.
Yeah. I think we have. Yes?
Has this work set precedents in other state capitals across the country?
Oh, I'm not sure if it has. You know, there's quite a bit of work in our neighboring states. Iowa, Kansas is undergoing a restoration right now. I would have to think that certainly we used very thorough and appropriate preservation approach to how we approached this work, looking at things in the long term, not making decisions based upon initial cost, but looking at them in terms of life cycle cost. For example, the roofing material that we chose, we were able to show that by using copper, we ultimately were saving the state millions of dollars by using copper rather than using a lesser quality material like a rubber roof or something to that effect. So
I think we're out of time, so.
are we?
Thank you
Oh,
very
okay.
much.
Thank you.